Hello everyone, welcome to today's live broadcast, Good Plastics, Bad Plastics, How Tubes, Plates, and Pipette Tips Can Affect Your Experiments. I am Bob Woodard of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots and sponsored by Eppendorf. Eppendorf is a leading life science company that develops and sells instruments, consumables, and services for liquid, sample, and cell handling performed in laboratories around the world. For more information, please visit eppendorf.com. Before we begin, we have a few important announcements to make. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many questions as we can. You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you have any technical problems viewing or hearing this presentation, please click on the support button at the top right of your presentation window or submit your problems through the green Q&A button lower left. I would now like to introduce today's speaker, Dr. Rafal Grzeskowiak. Rafal is a field application specialist responsible for the consumable products portfolio at Eppendorf AG headquarters in Hamburg, Germany. I will now turn it over to Rafal for his presentation.
All right. Bob, thanks a lot for this introduction. And hello everyone from my side as well, and welcome to our today's webinar. Good plastics, bad plastics, how tubes, plates, and pipette tips can affect your experiments. And I have to admit, I'm really delighted being here today and bring you this educational and, from my perspective, very interesting webinar. I just heard we have over 600 registered participants from all over the world, so it is indeed quite an event. And I believe the topic we will talk about here is still not very well recognized and often underestimated in the scientific community. But as you will see, it can have a tremendous significance to the daily routine in the laboratory. So let's move to the agenda of today's webinar. First, we will generally talk about factors influencing assays in the lab. Then in the second major part of the seminar, I will provide you some review on different classes of leachables and their relevance in the lab. And finally, provide some practical recommendations on how to minimize the influence of leachables. And finally, I will, of course, summarize the seminar. So, typical factors influencing assays in the lab. As you see on this graph, there are many factors influencing experiments or assays in the laboratory. And typical factors which directly influence basically you see it on the left side here, and they have direct influence, and those which have general have indirect influence, and are seen on the left side, on the right side of the graph. Let's consider first the assay-specific factors, those presented on the left side of the graph, and typically these are the factors most researchers or those who work in the lab are mostly worried with and try to control. So these include, first of all, samples, so their quality, integrity, and availability. Then, of course, some reagents, their quality, performance, and also lab equipment with its features and quality as well. Last but not least, great influence on assay performance has the preparation and handling of the samples. So again, these are the assay factors, and they have direct influence, and are typically basically regarded as most important in the lab. However, and this is seen on the second slide here, the general factors on the other side are believed to have rather indirect influence, are often regarded as basically not very important. The general factors are very heterogeneous group and may include things like personal skills, lab temperature, regulations, and many others. One of the factors, however, which is commonly underestimated and is still potentially very important, are laboratory consumables. And this is exactly one of the important topics of this webinar, the importance of consumables in the daily lab routine. Now, when we talk about importance of consumables in the lab, and in the workflows, and basically in general relevance in the lab, it is always confined basically just to the obvious features like lead tightness, purity grades, or centrifugation stability. And these important factors are basically always regarded by most of the researchers, they're perceived as important. And these by no means are important factors if of course have the impact on the performance of the experiments. There are, however, other less commonly perceived as important factors which, as you will see later, may have even more profound effects as commonly believed. And these factors are basically quality of consumables and closely related one, leachables, which means the substances leaching out of the consumables and influencing the experiments. And this is exactly the scope of this seminar. So let's recapitulate here the main messages and goals of this seminar for you again. I think it's pretty important always to set certain points, certain goals of the meeting or a seminar. And actually there are 3 points I would like to stress here. First of all, I would like to draw your attention to the importance of consumables and leachables as a crucial factor influencing your experiments. Also, I would like you to provide some comprehensive information on the very different leachable classes and which classes are critical, and provide you some examples, some specific examples on how the leachables can influence various assay systems. And last but not least, I would like you to provide some practical tips and recommendations how to assess and reduce risk of affecting your experiments through leachables. So these are the goals of today's seminar. I hope we will reach them. And basically we'll recapitulate at the end of the seminar and see if we really manage to achieve those. Before we proceed to the next chapter, however, let us do our first poll in this seminar and ask you a question to know a little bit more what the participants think. This will just take a minute or two. And the question is, basically, do you regard consumables as an important factor influencing your experiments? And there are 3 options to choose from. Feel free to answer this question, and we will have the results in a minute. This is actually a very tricky question when I do these seminars and I ask this question at the beginning. Yes, here we are, Paul, after a slide. And the results are, do you regard consumables as an important factor in influencing your experiments? 83.7% regards as yes, as important, 4.3% no, and 12.1% don't know. So basically this indicates kind of quite big relevance of consumables in the daily lab routine. It's quite a good result. Typically it's around 50-50 from my experience. So it's good to hear there is awareness of this topic in the audience. Thank you very much. We can continue with the next slide. And basically, I have to put it down. Let's continue and move to the next chapter, leachables and their relevance in the lab. Let me provide you at first some very important definitions actually. So what are leachables and closely related and often misunderstood term extractables? So leachables are essentially all chemical substances which can be released from a given container or consumable into the sample or a stored material under typical experimental conditions, which include experiment-specific temperature, time, and solvent type. So example here might be for leaching from a container to the drug preparation, for example, under standard storage conditions. It means, in other words, that leaching may vary according to these experimental conditions, and depending on them, different chemicals in their amounts might be present in the sample, and have, of course, then different effects on the experiment. So the very important thing is to remember this is the chemicals which leach under typical conditions. So it's not basically, it can vary. So this is a very important aspect to remember here. On the other hand, extractables are all chemical substances that can be maximally extracted from a given consumable under extreme conditions. And typically these conditions include quite aggressive organic solvents, high temperatures, and long incubation time. So after basically a long time and very harsh conditions, everything which can be extracted on maximum from a given plastic or from a given consumable is named extractable. So after explaining these two important definitions, let's move and talk about leachables and the influence they have in various areas of life. And as you see here, this picture of a nice child drinking from a plastic bottle, and leachables can affect our health. And this is actually still relatively underestimated fact. Leachables from various household items can affect our health, and basically in various clinical studies performed all over the globe, it has been confirmed that many leachables, particularly the classes shown here, phthalates and bisphenol A, are implicated in various health disorders in humans. And well, living in the modern world means, unfortunately, we are constantly exposed to various plastics and leachables from food and beverage containers, from tubings, carpets, cosmetics, and so on. And very high concentrations of leachables have been reported in general population. And their influence might be very pleiotropic, may be very versatile. So, for example, reduced fertility and reproductive tract abnormalities are very common, actually, effects, hormonal, brain, and behavioral disorders, but also impaired immune functions and various cancers. So this is how they affect our health. But leachables are also environmentally relevant pollutants, and phthalates, bisphenol A, and other leachables have been shown to act as so-called endocrine disruptors. This structure is very similar to some hormones, and they are directly targeting nuclear receptor transcription factors, and basically by doing this can disarray various signaling pathways and cause developmental and physiological effects. And these conditions are particularly profound in amphibians, and some of the examples are shown here. And the scale of the problem is immense. It's really huge. For instance, at least 8 billion pounds of BPA is being produced basically or used in the industry per year and partially released to the natural environment. And as a reaction to this, several countries started monitoring phthalates and BPA content in various products. In Canada, actually, the first country in the world declared BPA as a fully toxic substance and banned this substance. So, are leachables relevant in the lab? And how about our daily lab routine? And the answer is, oh yes, very much. And on the right side, you see the actually pretty famous science publication from Andrew Holt, where he summarized his research and actually pretty much shocked the scientific community by showing that substantial amounts of leachables are detected in common laboratory plasticware, and they can significantly affect and hamper many assay systems. And as you see here on this slide, after this publication, a real flood of various papers has been published, often in high-impact journals, where scientists from different walks of lab were reporting growing evidence for consumables affecting their experiments. And this, in turn, kind of revolutionized scientific community and led to conclusion that basically consumables and leachables were largely underestimated by researchers in the past. and basically pointed to high quality of consumables as a very important factor influencing various laboratory workflows. Now, as you might imagine, when assays go wrong in the research lab, it is pretty annoying. I can agree with this. As a scientist, I was working sometimes days or months, and some experiments simply didn't work. But if this happens in diagnostics, well, it gains a completely new dimension of significance, and it might mean the difference between health and disease. Well, sometimes perhaps difference between life and death. And here's one dramatic example published in Nature News from a medical center in Jerusalem, which was routinely screening patients for some relatively rare metabolic syndrome. And all of a sudden, all of the patients became sick, which appeared pretty strange since the disease is very rare, and it seems to be a real epidemic. And of course, the team stopped and investigated the routine assay methods, and after a month of investigations, it turned out that problems were caused by pipette tips they recently purchased and used for sample preparation. And as later revealed, this effect was caused by the dye solubilizing agent NP10. I'm not going into the detail what it means. It's a very hard chemical name. And this compound has been used during production process of the tips. So as you see, leachables may have also profound significance in clinical diagnostics. And now we go to the second poll. Bob, could you please start the poll? Basically, the question here is, how familiar are you with the topic of leachables? And let's see what the results are. We have also 3 options to answer: very, partially, not at all. From my experience, unfortunately, the awareness of the topic of leachables is still not very high in the scientific society. Let's see how high is it here. Okay. Well, how familiar are you with topic of leachables? 10.8% are very familiar, 60.8% partially, and 28.3% not at all. So at least there is a majority of participants who are partially familiar with the topic of leachables. This is very positive, actually. Let me close shortly the poll. And let's continue. So let's have some more detailed examples on how leachables can actually affect various bioassay systems in the laboratory. And here is one, a very nice example showing how leachables from a very regular micro test tubes can affect enzymatic assays. In the panel on the left, you see bars representing enzymatic activity in the presence of DMSO, which was only briefly rinsed through glass control or different micro test tubes. And here the tubes are shown are called S tubes. And glass, for information, is virtually free of organic substances and typically regarded as negative control in such studies. And as you can see, samples incubated in the plastic tubes show up to 40% inhibition of the enzymatic activity. And there is also a little interesting story to these figures. Andrew Holt, who published this data in the GIT lab journal, well, he as a pharmacologist was studying some promising drug candidates and was really interested in their inhibitory effect on some enzyme systems, and after years of research, he found a very promising compound, so he was very happy, and this compound showed, to his delight, a very high inhibition rates up to 40–50%. This effect, however, was very unstable, and upon closer investigation appeared to be, unfortunately, effect of the tubes he had in his lab, or more specifically, a slip agent being released to his samples, oleamide. So you might imagine his frustration, and actually this was the very reason he started as a scientist, seriously investigating leachables and their influence on the bioassays. So the conclusion here is enzyme activity can be significantly influenced by leaching of bioactive substances from the lab micro test tubes. Let's move to the second example. What we see here is basically a study which investigates effects of leachables on receptor binding assay. And by the way, this is one of the most commonly used assay system in pharmacology and drug discovery. So in this particular example here, the preparations of rat brain receptors were incubated with their specific ligand and ethanol washes from various laboratory tubes. And the panel on the left side shows basically percentage of specific binding of the drug to its receptor and the influence of different tubes. And the leachables from different suppliers can diminish drug binding up to 50% as compared to glass negative control. Well, notably, Eppendorf tubes show identical results as the glass control. So the conclusion in this example is that leachables may also affect specific binding of the receptor to its ligand, so basically receptor binding assays. So this is another very nice example of the leachables influencing different bioassays. But not only receptor binding or enzymatic assays can be affected by leachables, also very simple and actually routinely used assay of spectrophotometric DNA quantification can be also hampered by substances leaching from the lab tubes. And as the title here says of this slide, is it really DNA you're measuring? Well, not always. And the data shown here originates from a Biotechniques article published by Lewis and his group, and provides quite a striking evidence of some very mysterious nucleic acid molecules appearing in pure water samples upon short incubation. So in panel A, on the left side, you see a actually perfect DNA spectrum with the distinct peak at 260 nanometers, which is actually merely a heterogeneous mixture of UV absorbing leachables from the lab tubes which were used in this experiment. The leaching process is temperature dependent, and as you see on the panel B in the middle, basically it indicates that extended incubations at higher temperatures will lead to more leaching and absorbance. And finally, as shown in panel C on the right, leaching may lead actually to kind of false DNA amplification phenomenon, which is increasing DNA concentrations after heating the samples, as might be the case actually in PCR reactions, for example. And so this is actually a very simple assay, and from our perspective as company basically developing and producing and selling consumables, we were very much interested in this effect, and these false positive DNA measurements have been actually investigated in more detail by our application team at Eppendorf. We actually found this assay as a very quick and easy test indicative of general leachable levels and consumable quality in this respect. And in our experiment shown here, we did absorbance measurements of water incubated in different tubes. The conditions were 30 minutes at 95 degrees Celsius grade, and calculated theoretical DNA concentrations resulting from the absorbance at 260 nanometers. And the results are shown in the panel on the left side are quite striking. Even after relatively short incubation times, the amount of false DNA, so to say, was reaching over 2 micrograms per milliliter, which is actually considered as a pretty high and sufficient for most assays where DNA is used as a template. Well, in this case, we didn't do any of these assays, as it surely might be just frustrating. So the samples also showed high readings at 280 nanometer, which is typically used to quantify protein, and in this case also leading to false positive quantification. And well, let me conclude here. UV absorbing leachables can falsify spectrophotometric measurements of nucleic acids and protein. slowly losing my voice. Let me have a sip of water. So, how about the plates? We were talking mostly about the tubes and the experiments in the tubes and so on. How about the plates? And well, the answer is it might get even worse. And we used actually the same photometric assay to evaluate absorption spectra of water samples incubated in 96 deep well plates. And the resulting spectra are shown here and represent pooled 96 samples of 3 independent plates. And as you see, most of the plates from different manufacturers tested showed actually quite high levels of UV absorbing leachables. And this was pretty much consistent with our findings done with the tubes. We were not really much surprised. What was, however, very surprising is shown in the next slide. And this is the high variance between the wells. In this graph, the broad red line represents a variance of 96 individual wells of 3 independent plates, and is indeed very high. And this indicates actually that leaching process shows per se very high variability and potentially may falsify or increase variance in assays performed in plate format. So it literally means that dependent on the position of the well, different levels of leaching may occur, and therefore different effects on the assay may take place. It might be of tremendous importance actually for all those who work with different layouts, dilution series, or similar plate position dependent assays, for example in drug discovery. So basically, so far, these were some specific examples of assay systems where leachables have been shown to be an essential factor influencing them. And let's then finally see what are leachables exactly and which classes are critical. Let's go to the next slide. Let's do some chemical analysis of leachables. Now, if we made a very brief chemical analysis of a typical plastic tube or plate we have in the lab, we would see quite an interesting picture. In contrary to common belief, it is made not only of pure polymer. Apart from polymer molecules, laboratory plastic contains various polymerization byproducts like aliphatic hydrocarbons, oligomers, olefin clusters, and oxidation products, for example, alcohols, aldehydes, and ketones. But also, more interestingly, it contains various chemicals added during production process, additives, and their hydrolysis products. And this group is largely responsible for most of the negative effects leachables have on various assay systems. So let's have a closer look at the additives used during the production process. And in this very nice, colorful table, we have summarized most of them. There are many various additives used by manufacturers during production process of consumables, mostly to achieve certain properties of the consumable, or very often simply to reduce the production costs. And in the table are summarized most additives and are grouped according to their potential of negative influence on various assay systems. First group contains heavy metals, and those are used to catalyze the polymerization. Then we have stabilizers and antioxidants to stabilize the polymers and to extend the shelf life of consumables. And finally, pigments, of course, in case of colored consumables. And these substances cannot be avoided during production process. They have to be added simply to make the polymerization possible and make sure that consumables remain stable for a reasonable period of time. So they are regarded also as potentially uncritical, and there is not much evidence in the literature of their effects on experiments. However, I would really basically state here clearly that dependent on the experimental conditions and also assay methods used, particularly sensitive analytical methods, they also may have certain influence on experiments. So despite they look green here, they still might be an issue. Second group depicted in yellow is potentially critical and contains clarifiers used to increase transparency, so if a very clear tube or plate, it is already somehow suspicious. There are also antistatic agents to decrease electric charge, and a very heterogeneous group of surfactants and detergents to disperse pigments and other substances. And typically these substances can be avoided in the production, and as mentioned, have been shown to be potentially critical in some assay systems. And last but not least, at the bottom of the slide, the really bad guys. In red, you see the additives that have been shown in many publications to leach into the samples and pose a likely source of error in many assay systems. And the worst is these substances can be easily avoided and are added simply to reduce the production costs or make it faster. For example, sleep agents are used to remove the consumable from the injection mold, similar to when one does pancakes and puts basically butter on the frying pan. It makes easier to remove the pancake from the pan, but it makes it fat basically. And so the sleep agents remain in and on the plastics and may contaminate the samples. Also, the bioassays are critical and are added to prevent bacterial growth on the consumables, which might happen if the production conditions are not clean enough. And finally, the plasticizers. They are actually the classical leachables and serve mostly to make the consumables less rigid and prevent breaking. So again, all of the substances shown in red and yellow can be typically avoided in the production process of consumables and are either potentially or critical to most of the assay systems. Now, as you see here in this small literature digest, I hope you can read it. These substances are in most classical papers dealing with leachables and have been shown to make sometimes life of scientists miserable. What you see here is basically a lot of articles where different leachables from different consumables are shown and their effects on various experimental setups and assay systems, including enzymatic assays, receptor binding, cell growth, and spectrophotometric, and so on. Since you will be provided this full presentation of PDF later on, I will not go into the detail of each of these publications, but I think it's worth to read at least some of them later on. So this is basically a very interesting literature for all of you who are a little bit more interested in the topic. Let's summarize and make an important message in this seminar. There are, as you have seen, three critical classes of substances used during production process of consumables that may leach into the samples and negatively influence your experiments: sleep agents, bioassays, and plasticizers. And if I were to choose just one take-home message from the whole seminar, it will be definitely this one. So make sure you remember it. Now, well, I think it's enough of scaring you and showing all of these experiments being spoiled by leachables. And here I would like to give you some practical advices on how basically to achieve it, how to minimize influence of leachables, practical recommendations. Before, however, we proceed, I have the last question for you, and basically another poll. Did you experience problems in your lab routine due to consumables? I think it's quite interesting question to know. So let's start the poll. Bob, if we could start the poll. Here we are.
Yes. Yeah. The question is, did you experience problems in your lab routine due to consumables?
Yes, thank you, Bob. So most of the researchers, scientists, when they have the problems, actually, this is the very last thing they might think about, which causes problems in their experiments. So let's see what is the awareness here. Okay. Okay,
here the results are. Did you experience problems in your lab routine due to consumables? Often, 6.9%. sometimes 51.7%, never 6.3%, and don't know 35.1%.
Okay, thank you, Bob, for this result. So at least some of you had sometimes problems in your lab routine due to consumables. It's actually quite high results again. I will close the poll and continue. So again, in the last part, I will basically give you some practical recommendation on how to minimize the influence of leachables in the laboratory. And first of all, when we talk about practical recommendations, I would like to remind you one of the first slides in this seminar were assay-specific and general factors influencing experiments were discussed, and general conditions in the lab do include consumables and leachables and have to be considered and controlled. So what is important here is that this common mindset has to be changed to where only reagents and equipment influence your assays. And it is also consumables and other related factors like leachables that may have impact on your experiments. And here are some specific steps how to control and minimize effects of leachables. First of all, it is advisable to do kind of inventory of consumables you use in the lab. Very often we are not even aware of what we all have and what we use for a given experiment. So such inventory will give you a good overview of your situation and make it easier to react when problems occur. And very often they will occur, but typically we do not regard consumables as a cause. So in case of false or variable or irreproducible results, it is always wise to consider possible influence of leachables on your experiments and test respectively reagents, water, and consumables you are using. Standardization is also a good way to minimize effects of leachables, so using same consumables or even same production lots will decrease the variance in their influence on your workflows. And finally, a good lab practices are to order new consumables early enough and always test them against old batch in the same experimental setup you are using. And let's continue. Another extremely important point to understand is that despite superficial similarity, consumables are not created equal. Although tubes, plates, and tips may appear same to you, they may actually significantly differ in material and manufacturing, purity grades, and the performance. And these differences occur in the long process where consumables get the product specification, they are produced, and finally quality control takes place as shown in the upper part of the slide. So the important message here is the right choice of consumables has an impact on the outcome of your assays. And this is the last two slides with practical, three slides with practical recommendations. One of the most important practical recommendation is basically to choose right consumables. And firstly, there are many companies manufacturing consumables with various technologies and production standards. It is therefore essential to choose those manufacturers who comply with high quality and purity criteria and are respectively certified. And there are some important questions you should ask and get positively confirmed before choosing consumables from given manufacturers. So, for example, is the development and production of consumables according to international standards like ISO norm? Is the manufacturer ISO norm certified? It is also important that ISO norm is implemented in clean conditions and also high level of production automation is achieved. Another important question to ask is basically the quality and the purity of the consumables. And one very important point, which alone will definitely help you minimizing risk of leachables in your lab, is to choose consumables which are free of critical additives. So ask the manufacturer if their consumables are strictly free of slip agents, bioassays, and plasticizers. And telling is one thing and proving is another. So a very important thing here is asking for a respective certificate. Also, for sensitive assays and sensitive analytical methods like HPLC or MALDI, when possible, choose clear consumables to eliminate the influence of pigments and accompanying substances. And finally, it's always a good practice to ask for lot-specific certificates regarding consumables, quality and purity grades. Important here is that the certificate should be issued by external accredited laboratory and should be readily available online, which is not always the case. And last but not least, it's really important to get professional support in case of problems, so comprehensive sales and application assistance from the manufacturer side is really important in case of difficulties with your consumables or respective application. It will definitely save you time, money, and a lot of stress. So these were some practical tips and recommendations on how to minimize influence of leachables, and I hope it will really help you avoid major problems and improve your laboratory workflows. And one of the last slides, finally, what do recommend top scientists when it comes to leachables? Well, I have here a small citation from Andrew Halt's article in GIT Lab Journal, and he also, as an expert in the field of leachables, a leachable guru, as you might say, clearly recommends purchasing consumables from manufacturers that do not use additives and basically avoid suppliers that refuse to confirm the absence of such chemicals. And one of such manufacturers, Mr. Dr. Holt, recommends, after quite a laborious search, is Eppendorf, and I believe, and believe me, we did not pay him for this statement. It's kind of his original statement as a scientist. Now, the last slide is my personal recommendation to you in case you would like to obtain some more information on leachables and their significance in the laboratory. Visit our very interesting, from my perspective, website at eppendorf.com/leachables, where we place various information and additional resources on leachables, including many scientific articles, posters, and other scientific data, as well as relevant Eppendorf certificates regarding quality and leachables. And last but not least, a very interesting interview with Andrew Hall himself, where he talks about leachables and his continuing research on them. Now, we're slowly coming to an end of our webinar, so let me summarize the key points we covered here. I really hope to make clear this point here and make you really realize that despite common belief, consumables do indeed play a vital role in the laboratory workflow. I also hope this seminar provided you a good review on various additives used during production process and how these chemicals, by leaching into the samples, may hamper many assay systems. And as an important point, please remember the three classes of additives which are critical and shown in the literature to affect experiments, so slip agents, plasticizers, and bioassays. And finally, I hope it came clear to choosing high-quality consumables free of critical additives can significantly reduce the risk of negative influence on the experiments. Last but not least, I would like to end this webinar with a little cartoon from a German, pretty well-known journal named Laborjournal, which shows how a lab macrotube doesn't want to cooperate and says to the scientist, translated from German, well, you have to live with this if you take cheap material. And of course, this, apart from teaching you some German, I think reflects pretty well current developments and change in the awareness of scientific community regarding consumables and leachables and their significance in the laboratory. Thank you very much for your attention. And before we continue with live Q&A session, let me briefly do the last poll and ask you whether this webinar was informative for you.
Okay, here's the question is, was this webinar informative for you? Here are the results of that poll. Was this webinar informative for you? 80.2% said yes, and 19.8% said partially, and 0% said no.
Thank you very much. This is a very nice result. I'm really happy to hear this, and I hope you enjoy it. Again, thanks again for attention, and wish you all the best and good luck with your research, and have a nice day, afternoon, or morning, depending on where you are. Thank you very much. And
well, thank you,
yes, we can continue with the questions.
Yes, well, thank you for that informative presentation. Before we get started on the question and answer session, I'd like to remind our audience how to submit questions. You can submit questions by typing it in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many questions as we can. So let's get started. Our first question is, are leachables only relevant for assays with incubations in higher temperatures?
Okay, so I'll repeat the question just in case everyone hears it. Are the leachables relevant for assays with incubations in high temperatures? Yes, indeed. Leaching is a temperature-dependent process, and generally speaking, the higher the temperature, the more leaching occurs, and the data we have been showing here partially confirms this. There is, however, extensive scientific evidence that many critical additives, slip agents, bioassays are examples here, can leach already and strongly hamper various assay systems already in lower temperatures, also in room temperatures. There is a lot of evidence in the literature for lower temperatures. And the examples include various enzymatic assays, receptor ligand binding assays, and many others. And in the end, this is difficult to predict which assay to which extent will be influenced by given additive. So the best practice is here basically to avoid completely the critical additives.
Well, thank you. Yes. Mm-hmm. Next question is, most of the data you show refers to tubes and plates. What about tips? Do they also have some influence on the experiments?
This is actually a very good question. Yes, although the contact time of samples with the material of the consumables indeed much shorter in case of pipette tips than it is in tubes or plates, they may also have influence on the experiments. And some examples were already provided here. For example, arucamide, which is a slip agent from pipette tips, have been shown to inhibit G protein, coupler receptor assays, this is in this table, or dye-solubilizing agents inhibited some mitochondrial respiratory chain enzymes. This is this example from the clinical diagnostics. I would say very sensitive analytical methods like HPLC and MALDI may be also affected by leaching from tips. And there are many more examples in the literature on this. So in general, the more sensitive the assay or the method, the more likely leaching from pipette tips may influence it.
Thank you. Our next question is, does Eppendorf use critical additives during production of their consumables? Can a respective certificate be obtained?
Yes, that's quite a good one. During the production process, Eppendorf does not use any of these mentioned additives which have been shown in the literature to be critical. So Eppendorf does not use slip agents, bioassays, and plasticizers. It refers actually to all our consumables, tubes, plates, and pipette tips. And more importantly, we do provide a respective certificate of quality, which is basically available online or in each product package. So we do have such certificate.
Our next question. Can I use the UV leaching test with water incubation to check the quality of tubes I use in my lab? Yeah.
It is, in this test, actually, one class of leachables is evaluated, the UV-absorbing leachables, which are important but not the only one which has been shown to be critical. There are many other classes which are not visible in this test and still may be present in the given consumable and influence your assay. So basically, the message here, low levels of UV absorbing leachables, does not necessarily mean they're absolutely safe. Also, the conditions of the test and measurement of the spectra has to be optimal so that the results are reliable. And using diluted samples may lead to low signals and reliable readings. So to summarize, the take-home message here will be the UV leaching test may be done for some brief evaluation, but would still be cautious over absolute statements, and there might be consumables giving low absorption and still with high risk of influencing your experiments.
Here's our next question. What exactly are the UV absorbing leachables?
Yeah, well, in general, most organic compounds absorb to some extent UV light, and admittedly, highest absorption levels show usually aromatic hydrocarbons, and typically these are quite numerous additives with phenol groups. So, for example, phenolic antioxidants, stabilizers, clarifiers in their oxidation products. So basically, these are the major classes which absorb very strongly in UV region.
Thank you. Our next question is from Subramanya Bura of Gold Quality and Training Consultants. The question is, would getting consumables from one manufacturer eliminate leachables and extractables, or at least minimize them? Should we be able to detect these leachables and extractables and let the manufacturer know about these and be able to overcome them in some manner?
Can I see the question? Let me see the question because I didn't get it.
Well, I'll repeat it. Here it is. Would getting consumables from one manufacturer eliminate leachables and extractables, or at least minimize? Should we be able to detect these leachables and extractables and let the manufacturer know about these and be able to overcome them in some manner?
Yeah, in the end, the truth is that leaching process is kind of a very unreliable process. It has very high variance. And basically, of course, one of the factors which can decrease this variance is purchasing consumables from one manufacturer. So this is actually true. I would agree with this. Getting consumables from one manufacturer should, in the end, at least to some extent minimize the effects you see. And basically, should we be able to detect these leachables and extractables and let them know this? I would say the best practice here is to be in open dialogue with the manufacturer and ask it about these critical additives, and basically ask it about certification. And typically, a good quality manufacturer will provide and be able to basically at least kind of enter this kind of discussion and be open with you. So I think asking these questions I mentioned in the section where I was giving you practical recommendations is very vital here. And from my perspective, those serious manufacturers are always willing basically and provide this kind of information to you.
Our next question is from Charlene Jett, the 3 R's. She asks, have you been able to identify the leachables?
Well, the leaching process is strongly dependent on experimental conditions. And leachables are basically all of the organic substances which might come into the solution, might come into the sample under certain laboratory conditions. What we are stating is, I understand this question in this way, if Eppendorf basically provides consumables without leachables, we do not use any critical additives, and we basically certify the absence of these critical additives. However, there are some organic compounds which get out of our consumables and are present there. And basically, you could see this in using very sensitive methods like HPLC or similar. And basically, it is not possible to produce polypropylene or any other plastic consumable without any organic leachables coming into the sample. So it's virtually not possible. So basically, we don't have critical leachables. We might have some other compounds which are not very critical.
This next question is from Tim Gelhausen. He asks, for what materials are plasticizers used?
Well, basically, plasticizers are specific compounds which alter mechanical property of the plastic. And virgin polypropylene, for example, is very rigid material. And typically, they use basically to make the polypropylene more flexible. Otherwise, it will crack and have breaks after several weeks or several months of usage. So basically, plasticizers are used typically for polypropylene to make it more flexible, more plastic.
Okay, this next question is from Mubashar Rahman, the Department of Pharmacy, IUB, Pakistan. The question is, research shown here that Eppendorf is comparable to glass control. Is it true for all Eppendorf plasticware? Please also advise me on the volume range of Eppendorf tubes.
Indeed, the data which we show here, and actually this is data provided by in most cases, Andrew Holt, and he compared Eppendorf tubes in this case to the glass, and Eppendorf tubes indeed showed similar levels of a stressed UV absorbing leachables, which is just one class. So in this way, it is comparable, but again, it really depends on the conditions, and I would not really dare to compare Eppendorf plastic consumables with the glass. In many ways, they're actually one of the best available on the market. We don't use, again, the critical additives, and UV absorbing leachables are also very low levels in our consumables, but I would not really say that comparable to glass. And also advice on volume range of Eppendorf tubes. Well, the Eppendorf tubes are between 0.5, actually recently up to 50 milliliters. So we have the whole range. There are 0.5, 1.5, to also 5 milliliter tubes, 15 and 50. And all of these tubes are produced from the very same high quality virgin polypropylene. All of these tubes do not contain critical additives.
Our next question is from Jeffrey Kyle of Lurie Children's. The question is, there are two questions actually. First, how rapid does leaching occur? How temperature dependent is it? And other than cost,
sorry?
I'm sorry, there was just one last part. Other than cost, do the consumables with low levels of leachable chemicals have drawbacks? For example, shelf life, maximum centrifugation tolerance, temperature tolerance, etc.
So let me go for the first part of the question. I just scroll it up a little bit. How rapid does the leaching occur? And it depends really on the molecules. So the leachables is a very, very heterogeneous group of compounds. And some of them are small molecules, some of them are bigger. And then basically this largely influences the time of leaching. And the small molecules will go into the solution faster. It also depends if you use the water-based samples or organic solvents. So it's a very complex process. As a matter of fact, I would always say try to minimize basically using consumables with critical additives, and basically you're always on the safe side, because if you start going to this kind of discussions, it might work for some assays, but for the others will not. So it's always very difficult to predict. The same holds true for temperature dependence. Generally speaking, yes, temperature makes, the hotter it gets, the more leaching occurs. But again, as some examples shown in the literature, and I've been talking about it, basically provide the evidence that even in the lower temperatures, leaching occurs and may influence some assays, particularly assays which are sensitive. So again, there is no rule. And let me scroll. So other than cost, do the consumables with low levels of leachable chemicals have drawbacks? Well, there are high quality and low quality consumables, and there is a little bit more to the story of quality than just leachables. So there is basically the centrifugational resistance, there is how well they perform, the lead tightness, and so on. So it's basically, I would not just make this conclusion, little leachables have influence on the quality. The quality of consumable, which you're talking about, so shelf life, maximum centrifugation, is a function of many other factors in not only leachables. So again, here I would basically rely on the very old rule and basically approach and buy consumables from high quality providers. Typically, they will have less leachables, and typically they will have also all of other parameters better. Hope this answered the question.
Yes, we have time for one more question.
Sure, go on.
Excuse me, we have time for one more question?
Yes.
From Julius Akiyu, St. George's, University of London. Question is, to what extent do you think leachables affect DNA quantification?
Well, I've mentioned there are many classes of different compounds which are UV absorbing and mimic DNA or generally nucleic acids. And it really depends on the consumable. We were doing this internal test. Some of them we provided you here. From my perspective, in many cases, this leaching is very unreliable, so we can have one production batch and different tubes of plates with different leaching levels. So the effect is there, but it's very unstable and unreliable. I would say as a good answer here, or the basically practical tip is try to avoid tubes which are very clear. Try to avoid suppliers which basically use the critical additives or avoid confirming the absence, and basically try to minimize the risk according to these points I've been mentioning in the last section of the seminar.
Okay, well, I guess that's all we have time for today. I'd like to point out that a PDF of the questions and answers submitted during this presentation will be posted on the webinar login page in the resources section. With that, I'd like to thank our sponsor, Eppendorf, for making today's educational webcast possible. I'd also like to announce that today's webcast will be available for on-demand viewing for 6 months from today's date. You will receive an email from LabRoots alerting you when this webcast will be available for replay. We invite you to forward that announcement to your colleagues who may have missed today's event. So, thank you very much, Dr. Grzeskowiak, for your presentation, and we hope to see all of you again soon.
Thank you very much indeed again, and take care. Greetings from Hamburg to everyone.